you worry about what is going to kill you? Heart disease, cancer, a car accident? Most of us worry about things we can't control, like war, terrorism, the tragic earthquake that just occurred in Haiti. But what really threatens humanity? A few years ago, Professor Vaclav Smil tried to calculate the probability of sudden disasters large enough to change history. He called these massively fatal discontinuities, meaning that they could kill up to 100 million people in the next 50 years. He looked at the odds of another world war, of a massive volcanic eruption, even of an asteroid hitting the Earth. But he placed the likelihood of one such event above all others at close to 100%, and that is a severe flu pandemic. Now, you might think of flu as just a really bad cold, but it can be a death sentence. Every year, 36,000 people in the United States die of seasonal flu. In the developing world, the data is much sketchier, but the death toll is almost certainly higher. You know, the problem is that this virus occasionally mutates so dramatically, it essentially is a new virus, and then we get a pandemic. In 1918, a new virus appeared that killed some 50 to 100 million people. It spread like wildfire, and some died within hours of developing symptoms. Are we safer today? Well, we seem to have dodged the deadly pandemic this year that most of us feared, but this threat could reappear at any time. The good news is that we're at a moment in time when science, technology, globalization is converging to create an unprecedented possibility. The possibility to make history by preventing infectious diseases that still account for 1/5 of all deaths and countless misery on Earth. We can do this. We're already preventing millions of deaths with existing vaccines. And if we get these to more people, we can certainly save more lives. But with new or better vaccines for malaria, TB, HIV, pneumonia, diarrhea, flu, we could end suffering that has been on the earth since the beginning of time. So I'm here to trumpet vaccines for you. But first I have to explain why they're important. Because vaccines, the power of them is really like a whisper. When they work, they can make history, but after a while, you can barely hear them. Now, some of us are old enough to have a small circular scar on our arms from an inoculation we received as children. But when was the last time you worried about smallpox, a disease that killed 500 million people last century and no longer is with us? Or polio. How many of you remember the iron lung? We don't see scenes like this anymore because of vaccines. Now, you know, it's interesting because there are 30-odd diseases that can be treated with vaccines now, but we're still threatened by things like HIV and flu. Why is that? Well, here's the dirty little secret. Until recently, we haven't had to know exactly how a vaccine worked. We knew they worked through old-fashioned trial and error. You took a pathogen, you modified it, you injected it into a person or an animal, and you saw what happened. This worked well for most pathogens, somewhat well for crafty bugs like flu, but not at all for HIV, which humans have no natural immunity. So let's explore how vaccines work. They basically create a catch of weapons for your immune system, which you can deploy when needed. Now, when you get a viral infection, what normally happens is it takes days or weeks for your body to fight back at full strength, and that might be too late. When you're pre-immunized, what happens is you have forces in your body pre-trained to recognize and defeat specific foes. So that's really how vaccines work. Now let's take a look at a video that we're debuting at TED for the first time on how an effective HIV vaccine might work.
A vaccine trains the body in advance how to recognize and neutralize a specific invader. After HIV penetrates the body's mucosal barriers, it infects immune cells to replicate. The invader draws the attention of the immune system's frontline troops. Dendritic cells, or macrophages, capture the virus and display pieces of it. Memory cells generated by the HIV vaccine are activated when they learn HIV is present from the frontline troops. These memory cells immediately deploy the exact weapons needed. Memory B cells turn into plasma cells, which produce wave after wave of the specific antibodies that latch on to HIV to prevent it from infecting cells, while squadrons of killer T cells seek out and destroy cells that are already HIV infected. The virus is defeated. Without a vaccine, these responses would have taken more than a week. By that time, the battle against HIV would already have been lost.
Really cool video, isn't it? The antibodies that you just saw in this video in action are the ones that make most vaccines work. So the real question then is, how do we ensure that your body makes the exact ones that we need to protect against flu and HIV? The principal challenge for both of these viruses is that they're always changing. So let's take a look at the flu virus. In this rendering of the flu virus, these different color spikes are what it uses to infect you. And also, what the antibodies use is a handle to essentially grab and neutralize the virus. When these mutate, they change their shape, and the antibodies don't know what they're looking at anymore. So that's why every year you can catch a slightly different strain of flu. It's also why, in the spring, we have to make a best guess at which 3 strains are going to prevail the next year, put those into a single vaccine, and rush those into production for the fall. Even worse, the most common influenza, influenza A, also infects animals that live in close proximity to humans, and they can recombine in those particular animals. In addition, wild aquatic birds carry all known strains of influenza. So you've got this situation. In 2003, we had an H5N1 virus that jumped from birds into humans in a few isolated cases with an apparent mortality rate of 70%. Now, luckily that particular virus, although very scary at the time, did not transmit from person to person very easily. This year's H1N1 threat was actually a human-avian swine mixture that arose in Mexico. It was easily transmitted, but luckily was pretty mild. And so, in a sense, our luck is holding out, but another wild bird could fly over at any time. Now let's take a look at HIV. As variable as flu is, HIV makes flu look like the Rock of Gibraltar. The virus that causes AIDS is the trickiest pathogen scientists have ever confronted. It mutates furiously. It has decoys to evade the immune system. It attacks the very cells that are trying to fight it, and it quickly hides itself in your genome. Here's a slide looking at the genetic variation of flu and comparing that to HIV, a much wilder target. In the video a moment ago, you saw fleets of new viruses launching from infected cells. Now realize that in a recently infected person, there are millions of these ships. Each one is just slightly different. Finding a weapon that recognizes and sinks all of them makes the job that much harder. Now, in the 27 years since HIV was identified as the cause of AIDS, we've developed more drugs to treat HIV than all other viruses put together. These drugs aren't cures, but they represent a huge triumph of science because they take away the automatic death sentence from a diagnosis of HIV, at least for those who can access them. The vaccine effort, though, is really quite different. Large companies moved away from it because they thought the science was so difficult and vaccines were seen as poor business. Many thought that it was just impossible to make an AIDS vaccine. But today, evidence tells us otherwise. In September, we had surprising but exciting findings from a clinical trial that took place in Thailand. For the first time, we saw an AIDS vaccine work in humans, albeit quite modestly. And that particular vaccine was made almost a decade ago. Newer concepts in early testing now show even greater promise in the best of our animal models.